On November 24, 1944, a new reality dawned above Tokyo, Japan. The first large-scale B-29 raid on the city marked a turning point in aerial warfare, one that would haunt Japanese pilots for the remainder of World War II. On this day, 111 Boeing B-29 Superfortresses from the 73rd Bombardment Wing launched Operation San Antonio, targeting the Musashino aircraft plant on the outskirts of Tokyo. The B-29s flew at their operational ceiling of 33,600 feet, an altitude at which Japanese fighters struggled desperately to climb. The math of defeat was being calculated in the stratosphere. American bombers cruised at heights Japanese interceptors simply couldn't reach, and at speeds many couldn't match, even in level flight. They dropped bombs from altitudes Japanese anti-aircraft guns couldn't range. What Japanese military leaders had dismissed as American propaganda was proving devastatingly real. The B-29 Superfortress was more than just another bomber. It was a revolutionary weapon system that operated in a dimension Japanese technology couldn't contest. For the pilots tasked with defending their homeland, this revelation would transform a tactical challenge into a psychological trauma. They repeatedly failed to reach enemies floating serenely above them. A profound and demoralizing experience. The path to this moment had begun in June 1944, when American forces captured Saipan, Tinian, and Guam in the Mariana Islands. Japanese military intelligence immediately grasped the implications. From these new bases, B-29s could reach every major Japanese city and return. The Japanese homeland, which had never been successfully invaded, now lay exposed to attack from the air. The B-29 program had cost $3 billion, more than the Manhattan Project's $2 billion budget. Each aircraft incorporated revolutionary technologies. Pressurized crew compartments that allowed crews to work in comfort at extreme altitudes. A centralized fire control system with analog computers directing multiple gun turrets. And powerful R-3350 engines with turbochargers that maintained power where other engines gasped for air. The first B-29 to reach the Marianas was Jolton Josie, the Pacific Pioneer, which landed on Saipan on October 12, 1944, with General Hansel at the controls. Brigadier General Haywood S. Hansel Jr. had assumed command of the 21st Bomber Command on August 28th, bringing with him extensive experience in strategic bombing planning. The specifications told a stark story. The B-29's maximum tested ceiling was 40,600 feet, with an operational ceiling of 33,600 feet. By contrast, Japanese fighters struggled to exceed 30,000 feet in combat conditions. The Mitsubishi A6M-0, Japan's most famous fighter, had a theoretical ceiling that varied by model. But in combat configuration with full fuel and ammunition, it rarely operated effectively above 30,000 feet. On November 1st, 1944, an F-13, a photo reconnaissance variant of the B-29, from the 3rd Photographic Reconnaissance Squadron overflew Tokyo, the first American aircraft over the city since the Doolittle raid. This reconnaissance flight revealed the Japanese air defense's complete inability to intercept high-altitude intruders. Further F-13 sorties were conducted in early November to gather intelligence on aircraft factories and port facilities in the Tokyo-Yokosuka area. The F-13s were generally able to evade the heavy anti-aircraft fire they attracted, and the large numbers of Japanese fighters that were scrambled to intercept them. On November 24, 1944, General Emmett O'Donnell led 111 B-29s against the Nakajima Aircraft Factory. The raid came in at 30,000 feet, an altitude where the superfortresses were much safer from Japanese anti-aircraft fire. Japanese radar detected the incoming formation from 200 miles away. Fighter squadrons scrambled from airfields around Tokyo, knowing they faced a climbing battle against both altitude and time. The results shocked Japanese defenders. Only 48 bombs struck anywhere near the factory, as jet stream winds and clouds made accurate bomb aiming impossible. Yet, this tactical failure mattered less than the strategic revelation. Japanese fighters simply could not effectively intercept the bombers. Most interceptors never reached the B-29's altitude. Those that did arrived with engines overheating, controls sluggish from the thin air, and only minutes of fuel remaining for combat. The Nakajima Ki-84 Hayate, one of Japan's best fighters, had an operational ceiling that theoretically enabled it to intercept B-29s, but this assumed perfect conditions, a reduced fuel load, and high-quality fuel that Japan no longer possessed. In reality, Most Japanese fighters became combat ineffective above 25,000 feet. This disparity in operational ceilings created unprecedented challenges for Japanese air defense. It wasn't just that B-29s could fly higher. They maintained full combat effectiveness at altitudes where Japanese aircraft could barely function. The Mitsubishi A6M30 had a listed service ceiling of 36,150 feet, but this was achievable only under perfect conditions with minimal fuel and ammunition. Combat reports show that Zeros rarely operated effectively above 30,000 feet, and attempts to intercept B-29s at their cruising altitude typically failed. The B-29s maintained full combat capability at their operational altitudes through revolutionary design features. Their pressurized cabins meant crews operated in short-sleeved comfort, while Japanese pilots suffered from extreme cold and oxygen deprivation. The temperature at 33,000 feet could drop to -50 degrees, and Japanese pilots lacked adequate heating systems or proper cold weather gear for extended high-altitude operations. The fundamental problem facing Japanese pilots went beyond simple altitude numbers. Aircraft engines lose power as air density decreases with altitude. The B-29's turbo-supercharged Wright R3350 engines maintained sea-level power up to their critical altitude through General Electric Type B-11 turbochargers that used exhaust gases to compress intake air. Japanese aircraft engines, lacking effective turbocharging, lost power progressively with altitude. Due to the difficulty of intercepting and downing B-29s, Japanese fighter pilots increasingly perceived their efforts as being futile. Starting in August 1944, Japanese pilots occasionally conducted suicide ramming attacks on B-29s, and several specialized kamikaze fighter units were established in October. By the end of the war, ramming tactics had destroyed 9 B-29s and damaged another 13 for the loss of 21 fighters. The United States Strategic Bombing Survey conducted after the war provided a comprehensive analysis. B-29s flew 31,387 sorties against Japan, dropping 169,666 tons of bombs. Total losses were 414 aircraft, a loss rate of 1.3%. Japanese fighters accounted for only a small fraction of these losses, with most B-29s lost to mechanical failure, weather, or operational accidents rather than enemy action. The altitude crisis sparked frantic attempts at the technological solutions within Japanese aircraft design bureaus. The 204th Sentai, under Captain Terahiko Kobayashi, pioneered organized ramming attacks against B-29s on December 3, 1944. They claimed 6 B-29s were destroyed through deliberate collisions, with all Japanese pilots surviving by bailing out after impact. This extreme tactic arose from the simple fact that conventional interception at B-29 altitudes was nearly impossible. Major Kobayashi, who became the youngest Sentai leader in the Japanese Army Air Force when he took command of the 244th in November 1944, achieved 5 kills, including 3 B-29s. But these victories came through ramming attacks and low-altitude interceptions, not conventional high-altitude combat. The Japanese military developed several experimental high-altitude interceptors. The Mitsubishi J-Tanusam Raiden was modified with a turbocharger, theoretically capable of reaching 38,000 feet. However, the turbocharger proved unreliable, and only 35 of the equipped variants were built. The Kawasaki Kai-1 Rho-8 featured a pressurized cockpit, one of the few Japanese attempts at cabin pressurization. 4 prototypes were built, but the program was abandoned after a fatal pressurization system failure during testing. The Tachikawa Ki-94 was designed specifically for high-altitude interception, with a pressurized cockpit and turbocharged engine theoretically capable of reaching 45,000 feet. The war ended with only 2 prototypes partially completed. By late 1944, Japan's aviation fuel had deteriorated to 87 octane or lower, compared to the 100 octane and later 115 octane fuel used by American aircraft. This difference had catastrophic effects at altitude. Lower octane fuel caused engine knock and detonation, forcing pilots to reduce throttle to prevent engine destruction. This power reduction, combined with the already severe power loss from altitude, left Japanese fighters unable to climb to or maneuver at B-29 operating heights. Climbing to interception altitude required 3 times normal fuel consumption. Many fighters exhausted their fuel before reaching the B-29s, or had only minutes of combat time before being forced to break off and glide back to base. The fuel shortage created a vicious cycle where attempts at interception consumed irreplaceable resources while achieving minimal results. Japanese pilots encountered another shocking reality: the jet stream. B-29s flying from the Marianas discovered these high-altitude winds, which could exceed 200 mph. While American navigators learned to use these winds to their advantage, Japanese interceptors found them an insurmountable obstacle. Due to the jet stream at high altitude, which scattered bomb drops and made them highly inaccurate, the B-29s sometimes had ground speeds exceeding 500 mph when flying with the wind. Japanese fighters struggling to climb against the wind seemed to stand still in comparison. The jet stream's existence had been theorized by Japanese meteorologists, but they lacked the high-altitude capability to study or measure it. When Major General Curtis LeMay took command of the 21st Bomber Command in January 1945, he revolutionized B-29 tactics. On March 9-10, 1945, he sent 334 B-29s against Tokyo at night, flying at just 5,000 to 7,000 feet. This shift to low-altitude night raids might have given Japanese fighters an opportunity, but it presented different challenges. The Americans suffered few losses from Japanese fighters during the night raids, which were conducted from March 1945 until the end of the war. Japanese night fighter capability was primitive. Most pilots lacked instrument flying training, and ground control lacked effective radar guidance. The March 9-10 raid destroyed 267,000 buildings and 25% of the city. Of the 334 B-29s over Tokyo that night, only 14 were lost, mostly to updrafts from the massive firestorm created by incendiary bombs rather than enemy action. The raid killed an estimated 100,000 civilians and demonstrated that B-29s could operate with near impunity regardless of altitude. By early 1945, Japan's ability to mount high-altitude interceptions had completely degraded. Aircraft maintenance standards collapsed due to shortages of parts, tools, and experienced mechanics. Pilot training programs shortened from 2 years to 3 months, producing aviators incapable of the complex skills required for high-altitude interception. Resistance to the air raids decreased sharply from April 1945. On April 15th, the JAF and JN Air Defense units were belatedly placed under a single command when the Air General Army was formed under the command of General Masakazu Kawabe. But by this time, the fighter force's effectiveness had been destroyed. The 343rd Naval Air Group, formed in December 1944 under Captain Minoru Genda, specifically for home defense, assembled Japan's surviving aces flying the best available fighters. Yet even they could not overcome the laws of physics that prevented effective interception at B-29 altitudes. The situation became completely hopeless when P-51 Mustangs began escorting B-29s from Iwo Jima in April 1945. On April 7th, the raid on Tokyo was the first to be escorted by Iwo Jima-based P-51 Mustang, very long-range fighters from the 7th Fighter Command. The Americans claimed to have shot down 101 Japanese aircraft for the loss of 2 P-51s and 7 B-29s. In November 1944, only 20% of the airborne aircraft bombed the primary target, and 20% failed to bomb any target. In March 1945, 85% bombed the primary target, and in July, the percentage climbed to 94%. This dramatic improvement came partly from the elimination of Japanese fighter opposition and improved tactics. The ultimate demonstration of altitude superiority came with the atomic bomb missions. The practice missions flown by the 509th Composite Group flew at 30,000 feet, well beyond the range of most anti-aircraft guns. Japanese fighters did not attempt to intercept these aircraft, which were flying under the call signs Dimples 82, Dimples 83, etc. On August 6, 1945, the Enola Gay dropped the first atomic bomb on Hiroshima from 31,600 feet. On August 9th, Boxcar dropped the second bomb on Nagasaki from 28,900 feet. Both missions proceeded without any fighter opposition. Japanese interceptors simply could not effectively reach these altitudes. The last air combat of World War II illustrated the confusion plaguing Japanese air defense. On August 18, 1945, 3 days after Japan's surrender, legendary Japanese ace Saburo Sakai participated in the Japanese Navy's last wartime mission by attacking 2 reconnaissance consolidated B-32 Dominators. He initially misidentified them as B-29 Superfortresses. The encounter occurred at 6,000 meters, about 20,000 feet. where Sakai found the aircraft and noted that the single vertical stabilizer was enormous and swept upwards towards the rear. Characteristics of the B-32, not the B-29. This final combat, occurring after Japan's surrender on August 15th, resulted in the death of Sergeant Anthony Marion, the last American combat casualty of the war. Each B-29 represented technologies Japan had not developed: constant speed propellers with electric pitch control, turbo-supercharged engines, centralized fire control with analog computers, and pressurized cabins with heating and cooling systems. The industrial gap was not years, but decades. Each aircraft required over 13 tons of aluminum, half a ton of copper, 600,000 rivets, 9.5 miles of wiring, and 2 miles of tubing. American factories produced these components using mass production techniques that Japan had never implemented. While Japanese aircraft were still partially hand-built by skilled craftsmen, American assembly lines produced B-29s using standardized parts and processes. By October 1944, the 21st Bomber Command units were spread from Colorado Springs to the Marianas, with total strength reaching 43,000 personnel. This massive organizational effort demonstrated American logistical superiority, as clearly as the B-29s themselves demonstrated technological dominance. By August 1945, the 21st Bomber Command had destroyed a high percentage of Japanese industry, wrecked its economy, and shattered the morale of its people. The systematic destruction proceeded through distinct phases. The 21st Bomber Command attacked Tokyo 3 times between November 27th and December 3rd, 1944. 2 of these raids were against the Musashino aircraft plant, while the other targeted an industrial area using M69 incendiary cluster bombs. On February 25th, 1945, 172 B-29s. Dropping incendiaries destroyed 28,000 buildings, proving the effectiveness of incendiary weapons against Japanese urban areas. On April 2nd, more than 100 B-29 bombers attacked the Nakajima aircraft factory. On April 7th, 101 B-29 bombers attacked the same factory again. On April 13th, more than 300 B-29 bombers attacked military targets in and near Tokyo. The bombing campaign systematically destroyed Japan's industrial capacity. Aircraft. Industry. Raids on aircraft factories eliminated. Japan's ability to replace combat losses or develop new designs. The Nakajima plant at Musashino, repeatedly targeted, never recovered full production, oil refining. Systematic attacks on refineries reduced aviation fuel production to negligible levels by mid-1945. Transportation. Raids on rail yards and ports paralyzed the internal distribution of materials and food. Urban areas. On May 25, 1945, 464 B-29s bombed the Yamanote area, killing 3,352 people and destroying 166,000 buildings. According to the Metropolitan Police, Tokyo Station and the main building of the Imperial Palace were among the casualties. The B-29's altitude advantage came not from any single technology, but from integrating multiple systems into an effective whole. Turbocharging. The General Electric type B-11 turbochargers used exhaust gases to compress intake air, maintaining engine power at altitude. Japan had experimented with turbocharging, but lacked the metallurgy and precision manufacturing to produce reliable units. Pressurization. The B-29's pressurized compartments maintained a cabin altitude of 8,000 feet, even when flying at 30,000 plus feet. Crews could work effectively without oxygen masks for routine operations. Japanese aircraft had no pressurization systems in operational use. Engine technology, the Wright R-3350 duplex Cyclone, was a technological marvel. An 18-cylinder, 2-row radial engine producing 2,200 horsepower with turbocharging. Japanese engines, while reliable at lower altitudes, could not match this high-altitude performance. Fire control systems. The B-29's centralized fire control system used analog computers to automatically calculate lead angles and bullet drop. Gunners could transfer control of turrets, creating coordinated defensive fire that Japanese pilots found lethal, even when approaching from below. The only angle available given the altitude differential. While technology determined the outcome, the human dimension deserves recognition. Japanese pilots displayed extraordinary courage, attempting impossible interceptions. They climbed until their engines failed, Consciousness faded, and ice covered their aircraft, knowing they likely could not reach their targets. The repeated failure to intercept B-29s at altitude demoralized not just pilots, but the entire Japanese population. Citizens watched their defenders take off to intercept raiders, only to return, having never reached combat altitude. The psychological warfare value of B-29s flying unopposed over Japanese cities proved immense. Training programs collapsed as the war progressed. New pilots entered combat with less than 100 flight hours, compared to over 500 hours for pilots earlier in the war. These novices lacked the skills for complex high-altitude operations, making effective interception even more impossible. The maintenance crisis compounded the problem. By spring 1945, Japan's aircraft availability rate had fallen below 40%. Sophisticated high-altitude fighters required precise maintenance that became impossible with shortages of parts, tools, and experienced mechanics. Engines failed during climb attempts, often with fatal results, as pilots attempted to bail out from aircraft with jammed canopies. Another maintenance failure. The B-29 campaign's effectiveness went beyond simple bomb tonnage. Operating above fighter opposition allowed for multiple types of operations. Daylight, precision bombing, initial high-altitude daylight raids, while less accurate than hoped due to the jet stream, could proceed without prohibitive losses. Night area bombing. The shift to low-altitude night incendiary raids devastated Japanese cities while still avoiding significant fighter opposition. Mining operations. B-29s dropped thousands of mines in Japanese waters, effectively blockading the home islands. These mining missions proceeded virtually unopposed. Psychological warfare. Leaflet drops, warning of impending raids, demoralized civilians and demonstrated Japan's helplessness against air attack. Reconnaissance. Photo reconnaissance. B-29s mapped Japanese defenses with impunity, providing intelligence for invasion planning that ultimately proved unnecessary. The B-29's role in ending the war extended beyond the atomic bombs. Emperor Hirohito's surrender broadcast specifically mentioned a new and most cruel bomb. But the context was years of conventional B-29 raids that had already devastated Japan. The Imperial Conference that decided on surrender discussed the impossibility of defending against B-29 attacks. Military leaders admitted they could not prevent the destruction of Japan's remaining cities. The atomic bombs provided a face-saving excuse for surrender, but the conventional B-29 campaign had already made Japan's defeat inevitable. As Utaka Akabani, a senior civil servant, observed, it was the raids on the medium and smaller cities which had the worst effect and really brought home to the people the experience of bombing and a demoralization. By August 1945, Japanese industrial production had fallen to less than 15% of peak levels. The B-29's altitude advantage over Japanese fighters provides enduring lessons for military strategy. Domain control. Controlling a domain where enemies cannot operate effectively provides a decisive advantage. The B-29's ability to operate above Japanese fighter ceilings foreshadowed modern concepts of air superiority and domain dominance. Technology. Integration. Victory came not from individual technologies, but from integrating multiple systems, turbocharging, pressurization, fire control, navigation into a single, effective capability. Industrial base. Military power ultimately depends on an industrial capacity to produce and sustain complex systems. America's ability to produce nearly 4,000 B-29s while maintaining quality demonstrated industrial supremacy, as decisive as any battlefield victory. Training and doctrine. Technology without proper training and doctrine cannot achieve its potential. American crews underwent extensive training to operate the complex B-29 systems effectively. The B-29 experience influenced military aviation development for decades. The Soviet Union, having reverse-engineered captured B-29s into the Tupolev Tu-4, prioritized high-altitude capability in all subsequent bomber designs. The need to intercept high-altitude bombers accelerated jet fighter development worldwide and drove the development of surface-to-air missile systems. In the decades following the war, former enemies met at aviation reunions, revealing the human dimension of the altitude war. Japanese pilots who had attempted futile interceptions met American B-29 crews who had watched them struggle from above. These meetings revealed a mutual respect. American crews acknowledged the Japanese pilots' courage in attempting impossible interceptions. Japanese pilots admitted they knew from early 1945 that their efforts were futile, but continued from duty and shame at the alternative. The shared experience of aerial combat, even at different altitudes, created unexpected bonds between former enemies. The Japanese aviation industry's post-war development reflected lessons learned from the B-29 experience. Every specification for Japan's post-war self-defense force aircraft emphasized high-altitude performance. The trauma of being unable to reach B-29s influenced Japanese aerospace development for generations. The approximately 3-mile altitude difference between the B-29's cruising altitude and Japanese fighter combat ceilings determined the fate of nations. Those 15,000 to 18,000 feet of vertical separation meant the difference between effective air defense and the helpless observation of destruction. The shock experienced by Japanese pilots when first encountering B-29s at unreachable altitudes evolved through predictable stages. Disbelief that such altitude was possible, denial that it mattered, desperate innovation to overcome the gap, and finally, resignation to technological inferiority. This psychological journey paralleled Japan's path from confidence in ultimate victory to the acceptance of total defeat. For the Americans, the B-29 validated strategic bombing theory while demonstrating the importance of technological superiority. The ability to operate above enemy defenses transformed bombing from costly attrition warfare to systematic destruction with acceptable losses. The campaign proved that air power, properly equipped and employed, could be decisive in modern warfare. The B-29's success must be understood within the broader Pacific War strategy. While the altitude advantage was crucial, it combined with other factors to ensure victory. Island hopping campaign. The capture of the Marianas provided bases within the B-29 range of Japan. Without these bases, the altitude advantage would have been meaningless. Submarine warfare. American submarines had already devastated Japanese shipping, preventing raw materials from reaching factories that B-29s would later destroy. Code breaking. American intelligence knew Japanese fighter deployments and could route B-29s to avoid the strongest defenses. Industrial mobilization. America's ability to produce B-29s, train crews, and supply forward bases demonstrated a comprehensive superiority that went beyond just technology. The B-29 campaign succeeded not in isolation, but as part of an integrated strategy that attacked Japan from multiple directions simultaneously. The altitude advantage multiplied the effectiveness of these other efforts, creating synergies that accelerated Japan's defeat. The B-29 represented a revolution in military aviation that went beyond simple performance improvements. It demonstrated that warfare had entered a new technological age. Complexity could be reliable. The B-29 proved that complex systems could be mass-produced and operated reliably in combat conditions. Integration trumped individual excellence. The B-29's integrated systems proved more effective than individual pilot skill or courage. Industrial methods applied to war. Assembly line production of sophisticated weapon systems became the new paradigm. Technology could be decisive. The altitude advantage showed that technological superiority could render traditional military virtues irrelevant. This revolution influenced all subsequent military development. The emphasis shifted from individual warrior skills to technological systems, from craft production to industrial methods, and from tactical excellence to strategic capability. The shock experienced by Japanese pilots when B-29s flew above their maximum ceiling represented more than tactical surprise. It was the collision of technological reality with military mythology. The Japanese military had built its identity on spiritual superiority, believing it could compensate for material disadvantages. The B-29, flying serenely above the reach of Japan's best fighters and pilots, proved this fundamental assumption catastrophically wrong. Within 9 months, the B-29 force grew from a single bomb wing with 119 aircraft to 5 wings and 1,000 B-29s. This massive force, operating primarily from the Mariana Islands, systematically destroyed Japan's capacity to wage war while suffering minimal losses to enemy action. The statistics tell only part of the story. Behind the numbers were thousands of Japanese pilots who launched on interception missions, knowing they likely could not reach their targets. They climbed until their engines failed, their consciousness faded, and their aircraft became uncontrollable, watching helplessly as American bombers proceeded unopposed to destroy their cities. Japanese pilots, trained in the samurai tradition and believing in spiritual superiority over material factors, discovered that courage could not overcome physics, determination could not defeat chemistry, and spirit could not soar above an enemy's superior ceiling. The B-29s, flying above their maximum altitude, represented not just superior American aircraft, but the triumph of industrial democracy over military authoritarianism. The B-29's altitude advantage over Japanese fighters stands as history's clearest example of how a single technological advantage can prove decisive in war. Museums displaying a B-29 alongside Japanese fighters tell this story in stark physical terms. The American bomber's size and complexity versus the Japanese fighter's relative simplicity. Traditional design yielding to industrial innovation. Today, military planners study the B-29 campaign as a perfect example of asymmetric advantage. When one side can operate in a domain, the other cannot contest. Whether it's altitude, space, or cyberspace, traditional military superiority becomes irrelevant. The shocking realization by Japanese pilots that they simply could not reach the B-29s at cruising altitude was the moment when the Pacific War's outcome became inevitable. The legacy endures in modern military doctrine that emphasizes maintaining technological superiority and operating in domains where adversaries cannot effectively respond. The B-29s flying above. Japanese fighter ceilings were not just conducting bombing raids. They were demonstrating a new paradigm of warfare where technology trumps tradition, industry defeats ideology, and physics overcomes philosophy. The Japanese pilots who experienced the shock when B-29s flew above their maximum ceiling were witnessing the future of warfare. Their courage in attempting impossible interceptions deserves respect, but their failure was preordained by technological reality. In those futile climbs toward unreachable bombers, they experienced the defining truth of modern conflict, that victory belongs not to the brave, but to those who can operate where their enemies cannot reach. The story of Japanese pilots unable to reach. B-29s at altitude is ultimately a human tragedy wrapped in a technological triumph. Young men on both sides were caught in a conflict whose outcome was determined by industrial capacity and engineering capability, rather than individual courage or skill. The B-29s, flying serenely above desperate Japanese interceptors, became the perfect metaphor for the Pacific War. American technology operating beyond the reach of Japanese capability, delivering inevitable victory through industrial supremacy. That shock, that terrible moment of realization when Japanese pilots understood they could not reach the B-29s destroying their homeland, echoes through history as a reminder that in modern warfare, technological superiority can render traditional military virtues irrelevant. The B-29s didn't just fly above Japanese fighter ceilings. They flew above an entire worldview that believed spirit could overcome material disadvantage. In those unreachable altitudes, the age of industrial warfare definitively triumphed over the age of the warrior, writing the future of combat in contrails across the stratosphere.